Afternoon all. Now in the first part of this video I showed this, which is my battery powered, web enabled, Wi-Fi connected LED, which can be switched on and off remotely via the internet. Now it's not working now because I've flashed the original Espressive firmware back into the ESP8266 chip. So in this second part I want to go through all the steps that I took to get my web-enabled LED working. Now let's start with a stock module as it would be supplied from a Chinese seller, and I'll just go through which components I've added in order to make this project work. So let's just bring this down a little bit. You can see that this is positive and on the left here we have negative. So this corner pin here is VCC. Now you need this resistor. It could be a link, so in fact it could be any value resistor. I've gone for 10k. To this pin, which is CH_PD, chip power down. I think that means it kind of works as a chip enable. By pulling it up to VCC, we're enabling the chip. Ground is on this corner here. Now I've put this 2-pin link running from ground to GPIO 0, and that link needs to be fitted when we reflash firmware. And then the only other thing I've put on is this LED with a resistor, 470 ohms, between ground and the pin next to it, which is GPIO 2. I've moved my capacitor down here now out of the way. I'm not sure it's really doing anything particularly useful, so that you can see the other components I've attached. So now I've removed the batteries from the battery holder. I've connected this 4-way cable, which is RX, TX, VCC and ground, to my CH340 USB to serial converter. I've put the switch across to the 3.3 volt setting. Now although that changes VCC to 3.3 volts, I can't be entirely sure that it changes the RX and TX levels to 3.3 volts. It's quite possible I'm putting 5 volts into this chip. It's not specifically 5 volt tolerant, but you can probably get away with it. Now another point is that this CH340 USB to serial chip can't provide adequate current to drive the Wi-Fi module properly, but it is okay just for the purposes of transferring serial commands, flashing firmware and so on. Now the first thing I'm going to do is flash new firmware into the ESP8266. In fact, it's going to go into this chip sitting next to the ESP8266, which is a 4 meg flash memory. I'm going to fit the link onto my 2 pins. That connects GPIO 0 down to this ground pin at the bottom here. Now this module, as soon as I power it up, will be ready to have new firmware flashed. Now the firmware I'm going to flash is this Node MCU. It's at github.com/Node MCU. So if you want to learn more about Node MCU, go to nodemcu.com. Now initially that will bring it up in Chinese, but there's a link up in this top right hand corner for an English version of the website. So back on GitHub, and I'm interested in this thing, the Node MCU flasher. So let's click that. Now you can see that this is all relatively new. These items here were uploaded just 12 days ago, and down in this bottom right hand corner there's a download zip. So let's do that. Let's download the Node MCU flasher. So that gives me in my downloads a Node MCU flasher master zip folder, and inside that Node MCU flasher master. Inside that we've got a Win64 and a Win32 application. In resources and binaries we've got all of the binary files that the flasher sends to the ESP8266 chip. So I've now extracted the Node MCU flasher master folder from that zip folder. I've put it in my documents folder, and now if I go in here and Win64 release, here's the exe file which I'm going to run the flasher. If I do that, this rather nice flasher program appears. Now if I plug my USB to serial converter into my PC's USB port, it immediately sees that the converter is on COM5, which is very, very good. Now this is a very simple program. I can just hit the flash button and everything will just happen. But I'm just going to go into config for a moment, because you can see from this that it appears to flash 4 different binaries. This one flash at OX50s, IROM at 10,000, default at 7C000, and also blank at 7E000. But let's go back to operation, hit flash, and it all starts happening. Now it puts up this interesting barcode. It also shows you the MAC address of the access point and also the MAC address of the station. So I guess this chip has 2 MAC addresses. So it's flashed the first part. It's now flashing the second part, which I believe is the IROM part. Yes, that would certainly be the biggest part of the program. Lights are flashing. It all seems to be happening. This is looking good. So that's the IROM part nearly done. And that's it. You get a green tick, bottom left. It's all done. We can now remove this little link, reboot the module, and it should be ready to run Node MCU. So now I've rebooted the ESP8266 by just removing power momentarily, and I've just run up CoolTerm because I just want to briefly check that this thing will respond if I send a few commands. COM5, that's the COM port of this USB to serial module, 9600 baud. I am already connected. Let's just press return and see if it responds. And it has responded with this angle brace. So I'm now talking to the Lua interpreter. So if, for example, I say something like A, it says, yes, A, that's fine. What about A? If I say, well, it equals 5, it says, okay, A equals 5, that's fine. And then if I say something like print, open brackets, A, it responds with 5 because A equals 5. Now, if you want to learn more about Lua, you can go to lua.org, and it's all here on their website. Now, typing code into the Lua interpreter line by line using CoolTerm is okay for simple things like this, but it soon becomes apparent that it's a painful process for entering large amounts of code, and that's why I'm going to get rid of CoolTerm and switch to something, yes, I do want to close it, and switch to something called Lua Uploader. Now, I've tried various Lua senders and loaders, but Lua Uploader is the best of the lot. This is a program written by Harry Wiguna. Here's a YouTube video that he's put up on the Lua Uploader. Definitely worth a watch. Incidentally, here's the ESP8266 community forum at ESP8266.com. That's me. And here is the Lua Uploader on GitHub. So that's the thing I want to go to. So I downloaded this, what looks like the latest version, 1021.zip. And here it is. Here's the Lua Uploader by Harry Wiguna, 2014. Now, what we have here, COM port, COM5 I'm using, baud rate 9600. The line delay is inserted between lines of code sent to the interpreter. Because it is an interpreter, it can take a while to interpret each line. So this puts in a little delay, 200 milliseconds seems to work, between each line to give the interpreter time to do its interpreting. And this button's really handy. We can restart the ESP. If I hit that, you can see some flashing lights over here. And then it sent a node.restart, executed a node.restart. Some gobbledygook came from the module, and then it tells us that it's 0.9.5 build, 2015, January the 5th, powered by Lua version 5.1.4, and then it says cannot open init.lua. Now this is kind of a bootstrap program that you can put into the module. I haven't yet, so of course it couldn't find it. It can't open it, and now it's given me the interpreter prompt where I can start putting in my own Lua code. So now we need to head back to Node MCU on GitHub, github.com /node MCU, and the first link, node MCU firmware, takes us to all the parts of the node MCU firmware, but I'm interested in the README because this gives you an introduction to node MCU version 0.9.5, tells you a little bit about it, and this is important, the GPIO table, the GPIO pins and how they relate to the IO index. It has changed, so this is the old table before the 12th of December 2014. This is the new table after the 19th of December 2014. But further down, there's some stuff on flashing the firmware. Further down it says Start Play. Now this is where it gets very exciting. So first item, connect your AP. And here are some Lua statements to help us connect the module via Wi-Fi to my wireless access points. So let's take these two first lines. IP is Wi-Fi STA get IP, and then print the IP. So if we execute that, we should see what IP address this ESP8266 currently holds. I'll copy these lines of code. Now I've put these two lines into this immediate section. It's a really handy little thing where you can just execute a couple of lines of simple code, just very rapidly execute. Those two lines get sent. Now it's come back, print the IP, and it's come back nil. So this module doesn't actually have an IP address, and that's because I haven't asked it yet to connect to my Wi-Fi. So now what I want is this set of 4 lines where you can set the Wi-Fi mode to station, and you can enter the SSID and the password of my Wi-Fi, and then once again it gets the IP address and prints it out to the screen. Let me copy all of that. So now I've put these 4 lines into the immediate tab. I need to change the SSID to my Wi-Fi's SSID, which is git HQ. Let's do that now. And I also need to enter my password. Now my password isn't password, but for the moment I'm just going to pretend it is. I'm going to execute that. Now this sets it to a station. That's setting this module to a station. It gives it my Wi-Fi SSID and password, but it still comes back with the IP as nil. And that's because there wasn't time for this to go and get an IP address and have it come back with the result. So now what I'm going to do is I'm going to put the proper password in here off camera, and then we'll see the IP address appear here. So now I've commented out the first 2 lines. A double hyphen is a comment. So now all we're doing is we're getting the IP address and printing it. Let's execute that. So it sent that. We've got an IP address now. This has gone to the router, said, can I have an IP address? And it said yes, and it's come back with 192.168.1.129. Now back to the node MCU README file on GitHub. We just did this, connecting to the AP. Now I'm going to scroll down a little bit, and we've got this, a simple HTTP server. But this is very, very simple. All that happens is if you go to the web page, it just says hello node MCU. I guess we could give that a try. So I've pasted the simple web server into the editor tab. Now in the editor tab, it only executes what you select. So I'm going to select all of that, execute, and it's sent the web server to the module as Lua code. Now we can see if it works. Now this is the response. It just says hello node MCU. It was a bit hesitant, and part of the reason for that could be that this module is being powered by the 3.3 volts on my USB to serial converter, and it doesn't really have the current to drive this thing in Wi-Fi mode. So I'm just going to change the source code and try once again. So I'm going to change this bit here, hello node MCU, to hi Julian. Now I need to restart the ESP so it loses the previous web server. Select all of this and execute that. It creates a new web server. That all looks good. Let's go back to the browser and refresh that page. As I say, this might take a while because The web server is underpowered, it hasn't got the full current on 3.3 volts, and it's struggling. And after a bit of a struggle, it has come back, "Hi Julian." So the web server we know is working. But now we want a more complex web server, which allows us to enter the required state of the LED and to have it actually talk to the GPIO port to switch the LED on and off. Where do we find that? Well, back to NodeMCU on GitHub. They don't have it as one of the printed examples. If you go back to the top, in the list here, there's a folder of Lua examples. And in there, the bottom one is Web App Toggle Pin. And that's the one that I based my web server on. So if I click that, I can now copy and paste this code into the editor on the Lua uploader. Now these first two lines caused me a problem. Set mode Wi-Fi soft AP. Now I'm not sure what a soft AP is, it's probably a software access point, but I couldn't get it to work with these two lines in, so I'm going to comment them out. I'm going to put a double hyphen in between those two lines, and I'm going to rely on the fact that the module remembers its IP address. If I quickly flick back to the immediate tab and just execute that, it comes back and tells me it has an IP address. So I'm happy that it's connected to my Wi-Fi. Now, other things that I need to change. This number 1 here for GPIO number 1. My LED is connected to GPIO 2, but I can't put a 2 in there. I have to refer back to this table. This is the new table. Here's GPIO 2. It's IO index number 4. So I've set, where we set the GPI mode to be an output, I've set it to IO 4. And also down here where it sets it high or low, I've also put a 4 in those 2 points for GPIO, or at least IO index number 4. Now just a few cosmetic changes. I'm going to change hello NodeMCU to, I don't know, thank you Julian. And I'm also going to change this here where it says turn pin 1. I'm going to say turn LED. Now, rather than execute this, I want to save this code to the ESP as a file. And if I use this special file name init.lua, when I save this code to the ESP as that file, it will auto boot that every time you put power on. So let's save it. I'm also going to auto run it. Save it to the ESP. Now a whole load of file write commands come up here because it's saving every single one of these lines to the ESP. It's saying only one TCP server allowed. That's because I attempted to run it even though there was a TCP server already in there. Well, that shouldn't matter. But now if we take the power off this module, it should boot, execute this and be running that server. So now what I'm going to do is I'm going to disconnect my module from the USB to serial converter. Just pull those wires out. I'm going to put the batteries back in, and as soon as this thing receives power, like that, it should boot the init.lua file, and that should now be running the web server program. So will it work? Well, there's only one way to find out. Refresh this page. Aha! Thank you, Julian, it says. It's currently set to on. Let's set it to off, even though the LED is actually off. And that's not come back immediately. Haha! Problems! Well, it is working, it's just a little bit hesitant. If I set it to on, the LEDs come on, the status up here changes to on. Let's set it to off. As I say, it is a little bit hesitant. And I've even gone to the length of bending that LED away from the antenna in the hope that that might improve communication, but let me see if I can get this set up so it's a bit more reliable. Well, it's not really playing the game today very reliably, but that has gone on. And that has gone off again. Wait for the status to update. Now this thing's sitting in front of my computer monitor. It's quite likely getting lots and lots of interference. The tumble dryer is on at the moment, so there's all sorts of reasons why this might not be working very reliably, but that is the process that I used to get to this web-enabled LED. Let's just try it one more time. On. Yeah, that's gone on, and the status has updated. So that's really it.